So this video will show you how to create a dynamic amortization table. In this table we will be able to alter the repayment frequency from annual to semi-annual to quarterly and to monthly, and we will see the repayment amount, the principal amount, interest amounts all update accordingly. So in our table here we've got the input data, so we're assuming the annual interest rate is 6%. The term of the loan is 10 years, the principal amount of the loan received is 200,000, and that there will be a balloon payment of 50,000 at the end of the loan term. So when it comes to creating this dynamic table, we need to first of all create a drop-down list where we can specify what type of repayment frequency that we want. So in order to do that, we need to create, using the developer tab, we need to go into our insert, and then we go to combo box form control, and we create our drop-down list as follows. So what we do next, after we've created the box, we need to specify the list which we want to select from. So we right click on the box, we go to format control, and then within the input range we specify our list here, which is annual, semi-annual, quarterly and monthly. And next we want to specify the cell link. So the cell link will be any empty cell, and we will select cell F2 as the cell link cell. Then we click OK. So I will explain what these how this cell link cell will work. So from our drop down list we can select our repayment frequency. So what happens if I select annual, a number 1 pops up. What this number 1 basically means is that the annual item is the first item on this list. If I was to select semi-annual, it's number 2, which is the second item on this list. Quarterly is number 3, and monthly is number 4. The reason why this is important is because we will be integrating this cell within our choose function, which in turn will choose the correct time factor to apply to our interest rate and to our total periods. So I will explain that in more detail. So when we go to our time factor, what we essentially need is we need to be able to adjust this interest rate to reflect the repayment frequency, and also adjust the total periods in our model to also adjust the repayment frequency. So for instance, if this is an annual interest rate here, we've got 6%. If the repayment frequency is semi-annual, we have to divide the interest rate by 2. If it's quarterly, we divide it by 4, and if it's monthly, we divide it by 12 to get the correct interest rates. So in order to do that, we have to use the choose function. So what the choose function essentially is that it allows us to choose any item or value from a specified list, and the way it chooses the value is by using an index number. So this index number will be linked to this cell F2, which is the cell link from the previous combo box. And for the values, I'm going to be selecting 1, which represents our annual repayment frequency, 2 for our for our semi-annual repayment frequency, 4 for our quarterly repayment frequency, and 12 for our monthly repayment frequency. Then I'm going to press enter. So why did I choose these values? Well, you'll soon find out. So if I go to monthly, for instance, we'll see that the time factor will change, and go to quarterly it changes. I'll explain that in more detail soon. So now we move on to our adjuster rate. So what the adjuster rate is, like I said before, it adjusts this annual interest rate to reflect the interest rates depending on our repayment frequency. So how do we calculate that? Well, that's going to equal our annual interest rate, which is 6%, and we're going to divide it by the time factor here. Then we press enter, and that gives us the interest rate. So I'm going to format it so it looks like a it looks like a percentage format. So I'm going to format that so it looks better now, it looks more presentable. And now I'm going to go to the total period. So how do we calculate the total periods? Well, if our repayment frequency is annual, we'll have a single payment every year, so the total number of periods will be 10, or the total number of repayments will be 10. If it's, say, monthly, there will be 12 repayments every year, which signifies a repayment every month. So if we have 10 years, it will be 12 times 10. So therefore, the total number of periods will equal our term of the loan in years times the time factor. So it'll be C3 times our time factor. We press enter, and there we get the total number of repayments. So if we go back to our choose function, so you'll now understand why I picked 1, 2, 4, and 12. So if, for instance, I select an annual repayment frequency, the time factor is 1. What that means is our interest rate is divided by 1 to give us the annual rate of 6, which is correct, and the total number of periods will be the term of the loan in years times by the time factor 1, which gives us a total of 10 repayments, which also is correct. If I go to semi-annual, which is a repayment every 6 months, the annual interest rate of 6% is divided by 2, and the total number of repayments will be 10 years times 2, because there's 2 repayments every year, so that will give us 20 repayments or 20 periods in total. And if I select quarterly, the interest rate divided by 4 to give us a quarterly rate of 1.5%, and the total number of repayment periods for quarterly repayment frequency will be 40. And with monthly, it's the same thing. There's 12 months in a year, so the adjusted rate will be the annual rate of 6 divided by 12, and the total number of repayments will be our number of years 10 times 12 months in a year, which gives us 120. That's the reason why we selected the values 1, 2, 4, and 12 within our choose function. So now we move on to our amortization table itself. So here we will specify the formula. So I'm going to quickly change the payment type from 1 to 0. You'll understand what that is soon enough. So if I go to the period, so our first period is going to be number 1, and for the payment, this is essentially the total repayment that we will be making to the finance company. This will include both your principal repayment element and also your interest repayment element. So this will equal our PMT function. So we use the PMT function, which calculates the total repayment. And for the first argument, it's asking us for the rate, which is interest rate. We have to use the adjusted interest rate because this takes into account the repayment frequency. We then fix this cell reference because we want to refer to this cell always. Next, we go to the number of periods. The number of periods is essentially the total number of repayments in our model, which is 120. That's cell E5. We fix that as well. PV is essentially the principal value of the loan, the amount of loan you receive up front. That's going to equal this, 200,000. FB is essentially your balloon payment amount. What we have to notice is the PMT function is a cash flow function. So because when it came to the principal amount, because we were being given money by the finance company, that was a cash inflow, so we kept it as a positive value for the loan received amount. The balloon payment is the amount that you will pay out as a lump sum at the end of your loan term. So because it's a cash outflow, it has to be a negative. So we put a negative sign in front, then we select our cell reference for the balloon payment, then we fix that as well. And the type, so there's 2 different types of repayment. One will be at the end of each period, which is payment type of 0, which we've got here. Alternatively, you could pay at the beginning of each period. In that case, the repayment type will be 1. So if you were paying at the beginning of each period, you're repaying a loan at the beginning of each period, you would change the 0 here to 1. But in our case, because we are assuming we are repaying at the end of each period, we select the payment type cell reference C6, we fix that, and now we close our brackets, we press enter, and that gives us the total repayment amount. So we will be paying out of our own pockets £1,915.31 to the loan provider. Now we want to break down this total payment amount into its principal and interest components. How do we do that? We use the PPMT function, which is the principal payment function. We select the adjusted interest rate as our interest rate as before, we fix that, and now we've got a new argument called PER. So PER refers to which period we currently are in. So at the moment we're in period 1 right now, so we select this. We don't fix this cell reference because we want it to vary as we drag down this formula. NPER is the total number of periods in our table, which will be 120. We fix that cell reference. PV is the principal value of our loan, which again is 200,000. We fix that. And FB is the balloon payment. Again, because the balloon payment is a cash outflow, it'll be a negative sign. We then select the balloon payment cell reference. We fix that. And because we are paying at the end of each period, we select this cell reference and we fix that. I think in the previous formula, C6, is that? Yeah, that's all right. Okay, so of the £1,915.31p principal, of the £1,915 total repayment, £915 relates to principal repayment. So now, how do we calculate the interest component? Well, you could do the total repayment amount minus the principal amount, but Excel's got an interest payment function which we can also use, so I will be using that. So we can use IPMT as our interest payment function. We then select our interest rate as before. We fix that. PER, the current period is 1. We leave it as a variable cell reference. Number of periods is 120. We fix that. Principal value of the loan, as the loan is coming in, it's a positive value, so we leave it as a positive number and we fix that. FV is the balloon payment at the end, which is a negative value, so we put a minus sign, we select the balloon payment amount, and then we fix that. And the type, well, because we are repaying at the end of each period, it will be 0, so we just select that cell reference which contains the payment type, we fix it, then we close brackets and we enter, and that gives us 1,000 as interest. So if we sum together the interest and principal amounts, we get a total payment amount of £1,915.31p. As you can notice, it's all negative values. The reason why it's all negative values is because a payment is essentially a cash outflow, which is negative, and the payment itself is split into your principal and interest amounts, which are also cash outflows. Now we move on to our cumulative principal cell. The cumulative principal essentially tells you how much total principal you've repaid to date on your loan. So in order to do that, we've got to use the sum function. So we do equals sum, and we want to sum the principal. We want to sum a range of cells together. So this cell range will consist of the first principal payment amount in your table. So we have to fix this cell because when we drag the formula down, we always want the first cell in our range to be the first principal amount that we've repaid in period 1. We then, the formula's changed, sorry, let me just go back. So we select here cell C11, which is the first principal repayment amount. We then fix that cell. Then we have to insert a colon. And now when it comes to the colon, we want to sum a range of cells together. In period 1, because there's only a single repayment, we need to select this cell again. So we will be summing a range of this to this, which is basically one cell that we're summing together. I will be leaving it as a variable reference. The reason why the second part of the summation range is a variable reference is so that when we drag down our formula, this cell reference here will change to the cell below, and it will sum together all the cells within that range. Therefore, that will give us the total cumulative principal repaid. We then press enter, and that's our cumulative principal amount, which is £915.31p, which is the same as here because there's only been one payment. So with the cumulative interest, we use the same method essentially. So we do equals sum. We then select our interest paid in the first period. We fix that because we want a subsequent cell formulas to refer to this cell when we drag down our formula. So we fix that, and then we the second part of the range will again refer to the interest paid in period 1. We leave it as a variable reference so that again when we drag down the formula to the rows below, it will sum together all of the interest rates that are contained within that summation range. We then close our brackets and then we press enter, and that's the cumulative interest amount, which is again equal to the interest that we paid in period 1 because there's only been one repayment so far. And when the remaining principal amount is essentially how much principal you've got outstanding on your loan, how much you owe to the finance company as at that current period that you are in. So in our case, we'll do equals the total principal amount received, which is 200,000, and because we've got a negative value here, which is £915, we have to use the plus sign, and then we select the accumulated principal of £915.31p, and then we press enter, and that gives us the remaining principal amount. The reason why we use the accumulated principal amount is because we want to find out how much loan we've got outstanding at the end of each period. So we have to deduct the total principal received at the start with the sum of all principals that we've repaid to date, and that figure will be contained within the cumulative principal column. Now we move on to the next period, which is period number 2. So when it comes to this row, what we want in our table is that when we specify a specific repayment frequency, we want the table only to display the rows, the number of rows for that repayment frequency. So for example, if there's annual repayment amount, we only want there to be 10 rows to represent each repayment period. We don't want there to be any additional rows containing any error messages or etc., any other values that don't add any value to our table. So we want in those cases for those rows to return a blank value. In order to do that, what we have to do is we have to add some certain elements to our formula. So when it comes to specifying the period number, what we want is we only want there to be a period number if that number falls within the range for the total number of periods. So for example, if the previous row contained the period number of 120, we don't want there to be any additional periods because the previous row is the last period, so we want there to be a blank, and we want all subsequent values for all the other columns to also be blank. In order to do that, we have to use an if function, so it equals if the period value in the previous row, if that's less than the total periods, then we want there to be a period number which is one more than the previous row's period number. So we do if this value here in cell A11, if it's less than the total number of periods, then we want there to be a period number which will be the previous period number plus 1. If however, the previous period number is equal to the total number of periods, we don't want there to be any value. So we do, in that case, if the argument is false, we want it to return a blank. So a blank is signified by using 2 double quotation marks with no space in between. We then close the parentheses, press enter, and that gives us a period number of 2. Next we move on to the payment. So when it comes to the payment, again we want a payment value to be returned only if there is value in this cell here, in the period cell. So we do equals if this value here, if it's not equal to a blank, we signify a not by inserting a less than sign followed by a greater than sign. So if that value here is not equal to a blank, then we want the previous formula basically to reflect in this cell here. So in order to do that, what I'm going to do, I'm going to copy this, Control C. I'm going to go back to this payment amount here. I'm going to drag down the formula, and in front I'm going to paste the if argument. So if this value here is not equal to blank, we want a payment value to be returned. However, if it is equal to a blank, we don't want there to be any value, so we return a blank, which is 2 double quotation marks with no space in between. We then press enter, and there we have the payment amount. When it comes to the principal amount, okay, so what I'm going to do is I'm going to drag down this formula here, because remember, because we've left the period argument as a variable cell reference, when I drag down the formula, it updates to the correct period cell reference, which is why we left it as a variable reference. So now I've done that, I'm going to go to the front of the ppmt function, I'm going to paste the if function, And now, if that's equal to a blank, we want to return the principal. If cell A12 is not equal to a blank, we want to return the principal repayment amount. However, if it is equal to a blank, I just want to return a blank. Now we press enter, and that's our principal amount. We do the same thing with the interest amount. We drag it down. Again, because the period argument was a variable cell reference, when I drag down the cell, it updates to the correct period. So I'm going to go to the front of the IPMT function. I'm going to Control V. I'm going to delete one of the equal signs. Now I'm going to, the second part of the argument, I'm going to say, okay, so if cell A12 here is not equal to a blank, we want to return the interest payment amount. However, if it is equal to a blank, then we want to return a blank, which is no value. Press enter, and that's our interest amount. If I sum the two together, I will get 1915.31, which is equal to the total payment amount. So now we move on to the cumulative principal amount. So all we do is we drag down the formula from the cell above, and the formula updates correctly. The reason why it updated correctly was because when we specified the cell reference in the original formula, we specified a fixed cell reference for the first part of the summation range and a variable cell reference for the second part. So when I drag down the cumulative principal summation formula, it summed correctly because the first part of the summation range remained fixed, so it referred to the first principal repayment amount, and the second part of the summation range referred to the cell reference of the cell below, so we ended up summing the correct principal range. And now we need to insert the if function at the front, so I just paste that. So if the period value in cell A12 is a blank, is not equal to a blank, sorry, if it's not equal to a blank, then I want to see the cumulative principal amount. However, if it is equal to a blank, then I want a blank or nothing to be returned. I don't want to see anything in the cell if this value here is a blank. So press enter and we get the cumulative principal amount, so we can double check to make sure it's correct. If I sum the principal amounts together, I get 1835.19, which is the correct amount, and the same rule applies to the cumulative interest. So we just drag it down. We then paste the if function at the front. We then complete this formula, then press enter, and that gives us a cumulative interest amount. So if I sum the total interest together, I get 1995.42, and that is equal to the correct cumulative interest amount. Now we move on to the remaining principal cell. So we just have to drag down the formula from the cell above. I forgot to fix the principal cell reference C4, so we fix that cell reference, then we enter, and now we can drag it down, and as you can see, the remaining principal amount is equal to the total principal loan received minus the cumulative principal amount, because we specified a variable cell reference for cell E11. When I dragged it down, the formula updated to take into consideration the cumulative principal amount as at period 2. That's why we leave the second part of the sum as a variable reference, but we fix C4, which is principal amount, because we will always be referring to that principal amount in our formula. And now we need to insert the if function at the front. So we insert the if function. So if this cell here is a blank, then if it's not a blank, then we want to return the remaining principal amount. Otherwise, if it is a blank, we want to return a blank as well. So we press enter, and that gives us the remaining principal amount. Now, when I go to the cell containing period number 2, I have to fix the cell reference here because I forgot to do so before. So this cell reference is the total number of periods in our table, so you have to make sure you fix this, otherwise if you don't and you drag down your formulas, you will get error messages. So we just fix this cell reference, we press enter, Now all of our formulas updated correctly, we just have to drag down all the values, all the formulas in row 12. So we want to drag it down as far as possible to make sure the table, make sure it encompasses all possible rows that could potentially appear in our table. And if I go up, as you can see, our table has adjusted accordingly with all the correct payment, principal, interest, amounts, etc. So if we go down to the bottom, we should have a remaining principal amount at the end of the loan term as being 50,000, which would in essence represent the balloon payment. So if we go down, we've got 50,000 outstanding after we make all of these fixed repayments of £1,915.31p. So that shows that the model is correct because that 50,000 there signifies the balloon payment, which will be paid as a lump sum to clear off this outstanding principal amount. Now the flexibility of this table is that, say for instance, your repayment frequency will be annual. All you do is select the annual item on the list, and then your amortization table, it updates automatically. So you've only got now 10 periods to represent 10 annual repayments, and then we've got a 50,000 balloon payment at the end. So if we look at the interest amount, as you can see, if you go down the table, you can see that at the beginning you're paying more in interest and less in principal. However, as you go down, you're paying more in principal and less in interest. The reason why at the start, because your principal amount is higher and interest is being charged on a higher principal outstanding value, therefore the interest rate is greater at the start. So your repayment initially comprises mostly of interest. However, as you pay down your principal, the interest rate will go down because interest now is being charged against a smaller outstanding principal amount. And if we say change the interest rate to 5%, the payments update automatically. So our interest before, initially, our interest value, our total interest, accumulated interest was £69,256. If we change to say 10%, it increases to £144,000. And if say there is no balloon payment at the end, so you'll be paying the £200,000 off as periodic installments, you just have to enter 0 in here. As you can see, the remaining principal amount at the end of your repayment term is 0. And if we say if we repay our loan quarterly, which is every 3 months, so essentially there will be 4 repayments every year, we will have 40 repayment periods, which is correct. And at the end, because there is no balloon payment here, we will have 0 outstanding balance at the end. And if, say for instance, in this model we've assumed the payment type is 0, which basically means we are repaying our loan, each payment we are making at the end of each period. If for instance we have to make each repayment at the start of each period, we have to change the payment type from 0 to 1. And if we do that, as you can see, the amortization table, it automatically adjusts to reflect the change in when you repay each installment. At the start, because we are repaying the principal at the beginning of period 1, there will be no interest incurred. The full amount is principal. That's the reason why the interest amount is 0. We could also change the number of years in our loan as well. So if we change our repayment frequency to annual, we've got 10 annual repayments. If we say change it to 15 years, we've got 15 annual repayments to represent the 15-year repayment period. If you go below the table, you can see that even though we've got formulas within our cells, no value is being returned because I've specified that in my formulas I've specified that if there's no value in the period column, then I don't want there to be any value here. And I also specified in my formulas that if the value in the last row of the amortization table, if that's equal to the total number of periods, then I don't want a value to be returned for the period in the row below. So that's why there's no values appearing below the table, and that gives our table a very nice clean look to it.